Welcome to today's ArXiv CS Digest for March 13, 2026. We received 611 new computer science papers today across 54 subfields. Let's dive into the top picks. Trend 1 of 5, Neural Representations for Physical Systems. These papers explore using neural networks to learn efficient and robust representations for complex physical and scientific data. This cluster covers 127 papers. Representative work includes representation learning for spatiotemporal physical systems, MOEKD, mixture of experts' knowledge distillation for robust and high-performing compressed code models, and neural quantum states impurity solver for quantum embedding problems. Trend 2 of 5, LLM tuning and reasoning. This trend explores enhancing LLM capabilities through specialized tuning and advanced reasoning techniques for improved performance and safety. This cluster covers 178 papers. Representative work includes automatic in-domain exemplar construction and LLM-based refinement of multi-LLM expansions for query expansion, neuron-aware data selection in instruction tuning for large language models, and Navig AI tie-in, navigation by contextual AI and spatial audio. Trend 3 of 5, Generative Models for Motion and Media. These papers explore generative AI for creating and manipulating realistic and controllable visual content, from human motion to images and media. This cluster covers 84 papers. Representative work includes PhysMODPO, Physically Plausible Humanoid Motion with Preference Optimization, MIDIS, Taming Masked Diffusion Language Models for Sign Language Generation, and Let Your Image Move with Your Motion. Implicit Multi-Object Multi-Motion Transfer. Trend 4 of 5, Spatiotemporal Perception and Generation. These papers explore how to understand and create dynamic visual scenes and their underlying processes over time and space. This cluster covers 111 papers. Representative work includes visual ERM, reward modeling for visual equivalence, out of sight, out of mind, evaluating state evolution in video world models, and towards spatiotemporal world seeing graph generation from monocular videos. Trend 5 of 5, Quantum Computing and Optimization. These papers explore advanced computational techniques, from quantum algorithms to optimization methods, for solving complex problems. This cluster covers 111 papers. Representative work includes a note on publicly verifiable quantum money with low quantum computational resources, new quantum internet applications via verifiable one-time programs, and a generative model of conspicuous consumption and status signaling. Up next, our first paper out of 3, SPELL, Self-Play Reinforcement Learning for Evolving Long-Context Language Models by Zi Yang and Fei Huang from Sun Yat-sen University. Let's break down its key contributions. Proposes a multi-role self-play reinforcement learning framework that enables scalable, label-free optimization for long-context reasoning. This framework allows a single model to continually improve itself. Integrates 3 cyclical roles, questioner, responder, and verifier, within a single model. These roles work together to generate questions, answer them, and provide reward signals for training. Introduces an automated curriculum that gradually increases document length during training. This stabilizes the learning process and allows the model to handle progressively more complex inputs. Employs a reward function that adapts question difficulty to the model's evolving capabilities. This ensures that the training remains challenging yet achievable, promoting continuous improvement. Up next, our second paper out of 3, Causality is Key to Understand and Balance Multiple Goals in Trustworthy ML and Foundation Models by Ruta Binkite and Mario Fritz from CISPA Helmholtz Center for Information Security. Let's break down its key contributions. Integrates causal methods into machine learning to navigate trade-offs among key trustworthy ML principles. This approach addresses competing objectives like fairness, privacy, robustness, accuracy, and explainability. Leverages existing applications of causality in ML to align and balance multiple competing objectives. This is essential for achieving trustworthy outcomes in both standard ML and foundation models. examines how causality can be practically integrated into ML and foundation models. This offers concrete solutions to enhance model reliability and interpretability in real-world applications. Discusses the challenges, limitations, and future opportunities in adopting causal frameworks for AI. This paves the way for developing more accountable and ethically sound AI systems. Up next, our third paper out of 3, Aegis, No Tool Call Left Unchecked, a Pre-Execution Firewall and Audit Layer for AI Agents by Aojia Yuan and Yu Zhao from University of Southern California. Let's break down its key contributions. This initial stage extracts all potential strings from tool arguments, regardless of their type or nesting. It ensures that all executable content within arguments is identified for subsequent analysis. The extracted strings undergo a content-first risk scan to identify potentially malicious patterns or sensitive information. This allows for early detection of threats before policy validation. A flexible policy validation layer checks tool calls against predefined rules and security requirements. This stage ensures adherence to operational policies and allows for custom security configurations. All decisions made by Aegis are recorded in a secure, tamper-evident audit trail using cryptographic signatures and hash chaining. This provides a verifiable history of all tool call mediations.